Right, we now move to the gradient formula in our holiday homework. This work pertains to chapter 7.3 in both the 2-unit and the 3-unit textbooks. The gradient formula, as we know, is m equals y2 minus y1 over x2 minus x1. And this formula has been covered before in a junior year, but let's go and explore it a little bit more deeply now. So, looking at what the gradient really is, the gradient is, as we know, the vertical rise over the horizontal run. So, if we were to looking at, our vertical rise in all these triangles can be steep or getting less steep. So, the vertical rise divided by the horizontal run, and this is the horizontal run, sorry, the horizontal run there, there, and there. If this division is a high number, then we get a very steep line. If it is if the run is much larger in proportion to the rise, then we get a shallow gradient. And gradients are also defined in their sign. So let's just get to our work. And go forward. Yep. There we go. That we have positive gradients and negative gradients. Positive gradients lean to the right and negative gradients lean to the left. And what will happen is, as we use our formula, it would automatically sort out positive and negative gradients. The important part about using the gradient formula is, like the distance formula, we have to have a beginning and an end. But this time, we must always start with the y's on the top and x's on the bottom. And you always choose one to be your starting, your y2s and your x2s. So, going to our grid that we're used to, and we take our favourite point, which is 4, 5, as one of our points, and the other one we'll say this time is 2, 1. So let's bring that up, 2, 1, and here is the interval between them. Okay. So what is this, the gradient of this line? So once again, everything here is we've been doing so far has been based on a right angle triangle. So here's our right angle triangle, there and there, and this would be the vertical rise. The vertical rise is this distance here, and the horizontal run would be this distance here. Okay. So what is the vertical rise? The vertical rise is 1, 2, 3, 4, and the horizontal run is 2. And we know that the gradient, which is given the letter m, is vertical rise over horizontal run. And the vertical rise is 4 over 2, so it equals 2. Using the formula, we'll simply go m is y2 minus y1 over x2 minus x1. Now 2's are your start point and 1's are your end point. So let's have the start, or the beginning point, and the end point being down here. It doesn't matter which one you choose, once again, as your beginning or your end, but you've just got to be consistent. So we start with the y's first. So it's always vertical rise. The y's are rise. So we say 5, there's the 5 up here, minus 1. So it's 5 minus 1 on the top. And the bottom is 4 minus 2. And 5 minus 1 is 4 over 2. And you can see at this point here that we get, oops, we get the same thing here as here. So the formula really just simply works out the triangle and finds the gradient from that triangle without you having to take much drawing out at all. Okay, so that's the simplest version of it. So let's take one once again where we have some negatives. So we'll take this time a point, let's do 5, 4, and something down here And in that quadrant there, we'll have 1, -3. So here is the line that we're going to do. Let's do it from the old-fashioned method by making a triangle. So making a triangle here and here. So our vertical rise, 1, 2, 3, 4, 5, 6, 7, is 7. And our horizontal run is 1, 2, 3, 4. And notice the horizontal run is forward. Okay? So that means that the slope is going to be in a positive direction. So the gradient is simply 7 over 4. Now, if we use the formula, m equals y2 minus y1 over x2 minus x1. Once again, we always quote this formula before its use. You choose 1 for a beginning, right there, and 1 for the ending, right here. Okay. And we be consistent. It's the y's first, then the x's, always beginning minus end. So the top line will be 4 minus -3. So it's the 4, and here's the -3. Okay? Over the x's, 5 minus 1. So it becomes, the double negative there becomes 7 over 4. And once again, we get the answer the same way. Okay, so the use of the formula is quite straightforward. But what are some of the things that you'll be asked to do with this formula? Well, the first one is simply, let's just, while we pass it here, is to show that points are collinear. What does collinear mean? The definition of collinear means that they lie in a straight line. So collinear points here, over here, make a single straight line. These here make a bent line, so they are not collinear. So how do you prove collinearity? So prove that points are collinear. So to prove that 2 points are collinear, we show 2 things. We show that this interval and this interval have the same gradient. So this is A and B, and this is B, C. We show that this gradient, M1, must equal M2. And because they share the same point together, then they must form A to B and then B to C. Because they have the same gradient, this slope here is the same as this slope here, then, and they share a common point, they must be one straight line. So to prove points are collinear, you show that they have the same gradient and a common point. So that's the secret of collinearity, or if that's a word. Okay, now going back. So what are we asked to do in this exercise? The first is simply, once again, drill and practice, find the gradient between the lines. Then as you move through, you're going to be asked to, let's go over here a bit, you're going to be given a gradient and you have to find x. In the last exercise, we did the same thing with a midpoint. So here you would simply set up an equation and try and find x. Okay. Okay. Question number 6 says that you've got to show that these 4 points form a parallelogram. Now, a parallelogram is simply 2 sets of sides which have the same, four-sided figure, which have opposite sides as parallel. So what you need to do is you need to find 2 opposite sides. So looking at this one here, so just go back to my other work, you would firstly plot somewhere points so that you know which ones to prove there is our parallelogram, to say that that's what they look like. It's not, I'm just making these points up. And then you would say, okay, that's A, B, C, and D. We're going to prove that the gradient of AB must equal the gradient of DC, because they are opposite sides, and if they have the same gradient, they have the same slope. So you firstly find those 2 there and show that they have the same slope. Next, you would show that the gradient of BC would equal the gradient of AD. So we're now going to show that these two, here and here, have the same slope. If that is true, then it must be a parallelogram, because a parallelogram is just a four-sided figure which has two opposite sides which are parallel. And shapes which have the same gradient are parallel. So lines with the same gradient are parallel. Okay? And that's a good law that you should always remember. Okay. The last thing that we need to do is work out the, going back to this one here again and just clear this stuff there. We now need to also work out that the gradient of a line is actually equal to an angle that it makes with the positive direction of the x-axis. So let's have a look at just a line here. Let's get a line and pop it down. Okay, so we've got a line going up. Just move it over there a bit. Okay. Right. That line, as we know, as you can see here, is going through 1, 1, 2, 2, 3, 3, 4, 4. We know from just our simple mathematics that we've been doing for a long time that that's making a 45-degree angle with the x-axis. But how do we measure that 45? I'm measuring it in this direction here with the positive direction of the x-axis. Here's the positive end, and here is the negative end. I could have said it's making an angle of 135, which is this angle up in the back. But it's more convenient to, and makes more sense to measure it from the front end. Okay? So angles which, lines which are sloping forward, we always measure from the x-axis up to the line. Now, we know this has a gradient of 1. And how does this gradient work with this angle here? Well, it's just plain old trigonometry. If we just put a line going down there, let's make a different colour so it can be seen a bit better, and a line going along here, we know that this is 5 units and 5 units. And if we were to use this as a right angle triangle, then tan theta would equal 5 over 5, which equals 1. So therefore theta would equal tan the minus 1 of 1, which equals 45. We know that's in the first quadrant, so we don't need to worry about whether it's in the first or in the third quadrant, where tan is also positive. So it means that the angle theta, the tan of theta, which is this angle here, would actually equal the gradient. So let's just see if that's true in another form. So let's just start this all out. And now take another line. Let's make another line here, that's it. And let's make it go through there, through there, there. Okay, so now we've got the angle here as being theta. We want to work out this angle here. And if you look at the triangle, let's just find a little triangle that's been made. This triangle goes up there, down there. So this is a triangle over here. It's 1 across and 4 up. So theta there, tan theta, would equal 4 over 1. Remember, 4 is the vertical rise and 1 will be the horizontal run. So tan theta must equal the gradient. So what is theta in this case? Tan theta would equal 4. Theta would equal tan the minus 1 of 4, which equal, if we get our calculator up, and the scientific calculator, not and 4, and we're going to shift tan of 4 equals, these ones don't work, so up 10. So just pausing that while I try and work out how to use this online calculator. Yep, made it work. So it equals 76 degrees. It's actually very close to 76, it's 75.9. So it equals 76 degrees. Okay, to the nearest dp. If it is sloping backward, so once again, if we have a look at the previous annotations here, if the line sloped backward, line. If the line sloped in this way here, the angle would be still made with that direction there, so it would be a obtuse angle this time, and tan of an obtuse equals negative. So you'll get a negative value here. So if this was 135, for instance, tan of 135, that's 135 equals -1. So the mathematics works quite well when we are looking at this angle in an obtuse as well. So negative gradients have obtuse angles, and positive gradients have acute angles made with the axis. So looking at further stuff that you have to do with the textbook, this is question 13. It says find the gradient of a straight line that makes an angle of 45. We already know that one. That's a 1, so you can just write that one down. Let's just look at 14 instead, sorry. Okay, the gradient of a line, we have to calculate the gradient. We've got the angle here. So we know that the gradient, don't forget to write that the gradient is equal to tan theta. So it would be tan of 42 degrees 51 minutes. Okay? And since it's an acute angle, we're expecting a positive gradient. Okay, so I want you now to complete 7.3, the gradient. Thank you.